All right, today we are diving deep into one of the most out there, mind-bending ideas in all of science, the Sentience-Field hypothesis. Now, this isn't just some new theory about how the brain works. No, this is a proposal to completely rewrite our understanding of reality itself. And it does that by trying to answer the biggest question of them all.
I mean, think about it. Why are we here to experience the universe? Why aren't we just, complex biological machines, just robots going through the motions? This one question has kept scientists and philosophers up at night for centuries, and it actually sits at the heart of two huge universe-sized puzzles in modern physics. So on one side, you've got what's called the hard problem of consciousness, right? How does this lump of wet gray stuff in our skulls produce the incredible inner world of color and sound and love and pain? And then, on the other side, you've got the fine-tuning problem. This is the bizarre fact that if you changed any of the basic numbers of the universe, like the strength of gravity, by even a tiny, tiny fraction, poof, no stars, no planets, no life. It's like the universe was perfectly set up just for us to exist. And standard physics, it has absolutely no answer for either of these mysteries. This is where the Sentience-Field hypothesis, or SFH for short, comes in. It offers a single, really elegant and, deeply weird solution to both of these massive puzzles. But to even get there, we first have to take our most basic assumption about reality and flip it completely on its head. You see, the way we usually think about it is bottom up. We assume that lifeless, mindless particles, atoms and quarks, just bang around for billions of years. Eventually, they form super complex things like brains, and then, somehow, poof, consciousness just switches on. But here's the thing we have to remember. That's an assumption. It's not a proven fact. So what if we've had it completely upside down this whole time? What if consciousness wasn't the last thing to show up to the party, but the very first thing? And that question brings us to the absolute core of the hypothesis. Instead of a matter-first universe that somehow has to create experience, SFH suggests we live in a consciousness-first universe. So here's the big idea. SFH says that there's a fundamental field of pure sentience, a raw capacity for experience that underlies absolutely everything. So matter, energy, space, time, they aren't the bedrock of reality. They're actually projections from this field. The entire physical world we see is just a pattern emerging from a universal consciousness. The theory says this field is built from something called qualia. These are like the indivisible atoms of experience. Think about the redness of a sunset, or the feeling of cold, or the taste of salt. According to SFH, these aren't just descriptions of things, they are the raw data of reality itself. And the theory suggests the universe has a finite budget of these qualia to build with, and it uses them to construct every possible experience, from what it's like to be a quark to what it's like to be you. So this whole system, this sentient field, is in a constant tug of war, trying to balance two opposing forces. On one side, you have coherence. Think of this as stability, order, the universe's need to hold itself together. But on the other side, you have fertility. That's the drive to create new, interesting, complex things. The entire history of the cosmos, from the Big Bang until now, is just this massive optimization problem. How do you get the most complexity and novelty possible without the whole thing just dissolving into chaos? Okay. So how does a simple field that's just trying to balance these two forces actually build an entire universe? Well, the theory describes it as a kind of cosmic operating system. It basically works like this. The universe starts with its fixed budget of qualia, of raw experience. That budget then gets divided up or partitioned to create all these different patterns of experience. These partitions are then nested inside each other in this huge hierarchical structure, forming everything we see and are. And the whole system is constantly tweaking itself, trying to find that perfect sweet spot between stability and creativity. It's a universe that is, in a very real sense, exploring all of its own possibilities. Now, I know what you're probably thinking. This sounds fascinating, maybe a little bit like science fiction, but is it actually science? Or is it just a cool philosophical idea? Well, the people who came up with SFH argue that it is testable, and they point to some pretty startling results from both computers and labs. Okay, get ready for this number. Proponents of the theory ran this massive computer simulation. They basically created 60,000 different universes by tweaking the fundamental constants of physics at random. Then, they checked to see which of those universes were the best at balancing coherence and fertility.
The odds that a universe as perfectly optimized as our own would pop up just by chance? About 1 in 10,964,649.
And this chart here, this is what that actually looks like. Each one of those little dots is a simulated universe. As you can see, most of them are pretty boring. They're unstable, they can't support any complexity, but that gold star, that's us. That's our universe. It's sitting right on the bleeding edge of what's possible, what they call the optimal frontier. It suggests that our reality is anything but random. It's fine-tuned for experience.
And the main result from that simulation points to something they call the coherence first principle. So this graph here shows you the maximum possible fertility or complexity you can get for any given level of coherence or stability. And look at that curve. Nothing interesting happens. No complexity, no life, nothing, until you hit a really high level of structural stability. So first you need order, then you get creativity. And that's a core prediction of the hypothesis.
But it's not just computer models. The proponents of this theory point to a whole wave of recent, independent studies that they claim provide real-world support. They argue that these results, which are really weird anomalies for standard physics, make perfect sense in a universe that's optimized for this kind of deep interconnectedness. Each one, from quantum effects inside the brain to weird boosts in quantum learning, hints at a reality where coherence is fundamental, just like SFH predicts. But the hypothesis makes one final prediction that is, well, it's maybe the most stunning one of all. It takes us from quantum biology all the way out to the largest structures in the entire cosmos.
It predicts that the fundamental structure of reality is fractal, that it repeats itself in octaves. This means that patterns you see at the subatomic level will echo at the cosmic scale, and they're separated by a very specific, very strange mathematical constant, 10 to the power of 24.
So why that number? Why 10 to the 24th? Well, according to the theory, it's not random at all. It's a mathematical necessity. As a system gets more and more complex, it runs the risk of just falling apart into chaos. The math suggests that at this specific saturation point, the field is forced to jump an octave, to reboot the whole pattern at a new, bigger scale, just to keep itself stable. It's like a cosmic boiling point.
And they claim there is a smoking gun for this idea in actual astronomical data. It's something called the sigma-8 tension. The gist is, galaxies tend to clump together at a rate that standard cosmology can't quite explain. The observed value is 0.75. What's so special about that? Well, it just so happens to perfectly match a universal metabolic scaling law that we see in biology, in everything from single cells to blue whales. SFH says that's no coincidence. It's evidence of the same underlying operating system running the show across all scales of reality.
So, in the end, the Sentience-Field hypothesis gives us this radical new picture of everything. A universe that is, at its core, pure experience. A system that's constantly tuning itself for stability and creativity, repeating its fundamental patterns from the unbelievably small to the cosmically vast. It's a single idea that tries to solve our deepest scientific mysteries by putting consciousness not at the end of the story, but right at the very beginning. Which, of course, leaves us with one final, very big question to think about. Thanks for watching.